English version TTR. Hello and welcome back. Today I bring here a D700 inverter from Mitsubishi Electric, but what will be explained here also applies to other Mitsubishi inverters. And the Schneider PLC that here is an M241, and what will be explained here I believe that also applies to other Schneider's PLC. So what we have here is a communication RS485, actually RS422. Let me take out this cover. I'm using the RJ45 port of D700. If you are using an AF100, you may use its internal terminal block, but the parameters numbers change. Here we will set parameters from 117. If you are using an inverter F800, you will set from parameter 330. So this cable is connected to channel 2, line 2 of Schneider PLC. So we have here its terminal block, D0 and D1, and from D0 and D1 it's connected to the inverter. The cable configuration will be shown in your video, so you can see how this cable was assembled. Remember that RJ45 pinout is counted with the clip away from you, left to right, from 1 to 8. Okay, so now the first thing we have to do with this inverter is parameterize the inverter in the way it can communicate in Modbus. Modbus RTU in our case. So first things first, I will change the parameters that will be shown to you on your screen. So to change the parameters, I remind you need first to change from EXT to PU mode. To do that, I will click the button PU EXT. For this operation to be effective, you must have your parameter 79 in 0, what's the factory setting. When the inverter is in PU mode, it means that all the operations, including parameterization, is done from this front panel of the inverter. Another thing I will do is disconnect this communication cable for a while. This way I avoid any interference in the parameterization. After this, I'll do the parameterization on the inverter. One important explanation is that the parameter 340 enables the communication via network. If the parameter 340 is in 10, I can change via front panel from PU to network mode. Once I changed all the parameters, I'll cycle power to make them take effect. Okay, now the inverter is powered on again. Now what I will do is to program the Schneider PLC using the same settings of the inverter. So let's quick review the settings we did. We set this inverter as station number 1. The speed is 19,200 bits per second. The parity is even. And obviously, the protocol was set as Modbus RTU. Okay, so let's open now the Schneider's software. Okay, so here I have a virtual machine where I will open the Schneider's software. Okay, so here it is. So machine software, version 4.3. Okay, so once the software is opened, I will create a new project. This will be an empty project, and the name will be the 700 M241 Modbus. After that, I'll add a device in Manage Devices, Logic Controller M241, and the exact PLC model we have, if we take a look on its front cover, it's an M241 CEC24T. That's the model that's here. Okay, so let's add this exact model to our project, clicking here. Okay, so once we added our PLC to the project, next I will click OK here. And then let's program the controller directly. Just press Start. So now we can see all the configurations of the PLC. And now I will change first the serial configuration of the line 2. That's where our inverter is connected to. So I'll click here in Modbus Manager. I'm not going to use that. I will delete it. Okay, I'll click here in the plus button. So then the available protocols will be shown up. And I'll choose Modbus I/O Scanner. I will add it. Don't close this window. Click down here in I/O Scanner. So it will update the list of the protocols that I can put under I/O Scanner. And then I'll put here generic Modbus device. I'll add it here. And that's it. So here I have the configurations of the Modbus itself. Let me maximize this window to see it better. Okay, now I will set it as my station number 1. It will be this device here. Let me change its name so we can easily locate it in the software. Properties. Let's put station 1, inverter, D700. It's easier to locate it in our software. So here we will put our channels. We don't need to change the initialization. Everything else is just fine. So now there's an important configuration here. That's the communication, serial communication. So it needs to be aligned with the same configuration we have in our inverter. So we'll double click here. And then you will see that the standard configuration is the same that we have in our inverter. So it's exactly what we have there. We don't have to change. You have to configure it exactly as we have in our inverter. Otherwise, it will not work. Next step is to configure our channels. And our channels means the Modbus registers that we have to work with. Those will be shown in your screen now. So from these registers, we will be able to write and read data to and from the inverter itself. Okay, so then I will create a channel here. And the first thing I will add here, it will be the digital status of the inverter. I'll put a name here, status, dish, INV. So this is going to be the inverter status. Okay. So I'm going to read a holding register. And one important thing to say is that if you see the inverter data table, you will notice a number 4 in the beginning of each address, as you can see in the register shown in your screen. This number 4 in the beginning is not part of the register address, but just an indicator of the register type, in this case a holding register. We must not put this number 4 in the configuration of the address in the master. There is an additional rule for setting registers in the master. You have to subtract 1 from the register address shown in the inverter data table. For the inverter status register shown in your screen, for example, taking the last 4 digits, you have the number 9. Subtracting 1 yields 8, so 8 is the number you must put in the master. Notice that the address shown in the inverter manual is in decimal. Normally, there are 2 ways to represent Modbus addresses: decimal or hexadecimal. In our case, the address must be set in hexadecimal, so take care about it. So next, I will add a writing channel. I will add the register for digital commands such as rotation start or multi-speed. If we look in the table for this register, we will notice that it has the same address for getting the status with 16 bits. Writing it, we send commands. So set bit 0 for stop, bit 1 is start forward, bit 2 is start reverse, bit 3 is for high speed, and so on and so forth. If instead of writing we read this register, the bits assume different function. So bit 0, for example, assumes the function of giving back if the inverter is running or not. Bit 1 will give us the information if it's running forward. Bit 2 if it's running under reverse. Bit 3 if it reached a certain frequency set in the parameters, and so on and so forth. So I will add the same register here for writing, taking in account that it has different functions if read or written. Let's add a channel then, and I'll put the name CMD Digital INV. Then I'll change the function of the channel for writing this register. And then here I'll put the address 0008. So let's add another channel now to get what's the current inverter speed. Let's put its name as current speed. If we go to the table to check which register has the speed information, we will notice that's the register 201. Remember that we have to remove the digit 4 and convert the number 201 in hexadecimal. That's what I'm going to do here in my calculator. So let's put here 201 in decimal, and you can see here the equivalent in hexadecimal, that's C9. And then we have to subtract 1 from C9, yielding C8. Now, next channel I will add is to send a speed set point to the inverter. So let's put its name as set point speed. If we go back to our table to check which address is designated to set the speed, we will find that the register number is the register 14. We will choose the address 14 instead of 15 because it is the RAM address. As we will write the set point every scan, it's not good to do that in EEPROM memory because it may fail prematurely. The address 14 is in decimal, so we have to convert it to hexadecimal. So let's do that. And the correspondent for 14 decimal is 0e in hexadecimal. Of course, to set the address in our channel, we must subtract 1. So I'll put here 0D. Okay, so here we have set the main functions for the inverter, as you can see. So digital status, digital command, current speed, and speed set point. So let's write these configurations to our Schneider PLC. Just for understanding, notice that my Schneider PLC is connected to the PC via Ethernet cable. So that's the way I'm going to download the program to Schneider PLC. So to download the program, I go to login. It will give me this warning window. I just press Alt plus F to continue loading the program to the PLC. It will ask me about if I am sure. Yes. Again, I really want to load the program. Yes. And it's done. After downloading the program, notice that we are online, monitoring PLC status. These icons indicate if functions are operating correctly or not. And in case of the inverter, you can see there is a triangle here, what means that the communication function has problems to communicate with the inverter. This problem in our case may be discrepancies between the configuration set in the inverter and the PLC, or some disconnection, physical disconnection from the inverter to the Modbus PLC line. If you remember, in the beginning of this video, I disconnected the cable from the PLC to the inverter to parameterize the inverter. And it's disconnected now, so that's the reason why the PLC cannot connect to the inverter. So I'm going to reconnect this cable here. So I'm going to remove the cover and put back the cable to its original place. That's here. And I'll put back the cover. That's it. So now if we go back to the software, we will see that where we have the inverter in this project tree, you can see there's a green icon here, meaning that the communication is occurring without any problems. Okay, once my communication is fine, next step is to test sending commands and reading status from the inverter. And that's what we're going to do now. So first of all, if you notice, if you come here to our variable table, you will see that the inverter variables we set are associated with some variables in the PLC, such as you can see here in the address. And that's the variables we're going to use to set the informations or commands and read the status from the inverter. So in order to do that, I'll go to a window there's here in the software, call it watch, and it's here in view, watch 1. Okay, and here I'm going to put those addresses so we can modify its values in case of commands, and we can see the values coming from the inverter in case of the status. So let me put all the 4 variables here. And now let's do some tests and see if the inverter is responding. Okay, so here is my inverter. So we can see what's going on here. And let's retrieve the information of our registers. What does it mean, every one of the bits, so we can set accordingly and see what's the result in the inverter. So here you see the table. And we are going to change this register for the command. Okay, so let's put the value here. Let's put in binary so we can set it better, and you can see and make a relationship between the value I'm putting here to what you will see in the inverter. So first I set the bit 1, that's a forward rotation command, and as you can see in the inverter, you can see that the run LED is blinking because we don't have any speed reference value so the inverter can follow it. But it's an indication that the command that we are sending to the inverter is being received and processed. So next, let's set a reference speed to our inverter. So I'm going to use the digital commands. We already set the forward rotation command. And now to give the inverter a fixed reference based on the mode speed, I'm going to set here the bit number 3. So the inverter should go to the high speed command reference that's 60 Hertz. So let's do that now and let's see what happens. Okay, you can see here that the inverter just obeyed the command and reached 60 Hertz as commanded via the third beat here. Okay, so now I will set the speed with a specific value through this last word. But first, I will stop the inverter, writing 0 to this digital command word. So all the bits are going to 0. And this means that the inverter will stop and will cancel the speed reference. It's just reducing the speed until 0. As you can see here, we can read the current speed. And now in this register, that's the register 201, I'm going to write the speed here. And the way I write the speed here is multiplying the value of the speed that I want by 100 and writing its value here. So, for example, if I want 20 Hertz, I must write 2000 here. That means 20 Hertz. And if I go here in the digital commands and just set the beat for a forward rotation command and force it, you will see that the inverter goes to 20 Hertz. As you can see here. If I change the speed to 3500, it means that the inverter will go to 35 Hertz. That's what just happened here. So that's it for this video. This is the basics about how to communicate a Schneider PLC with a D700 inverter via Modbus. I hope you enjoy it. And if you have any questions, put in the comment section below. I'll be glad to answer. So thank you and see you next time.